Hello and welcome to today's webinar. Our product manager, Raj Singh, will talk about the myriad ways to use Python with InterSystems IRIS and InterSystems IRIS for Health. Please know that this webinar will be available for playback and you may type questions into the chat at any point. These questions will be answered on live audio at the end of the presentation. With that, I hand it over to Raj.
Thanks, Kate. It's great to be here today to talk about using Python with InterSystems IRIS. As Kate said, my name's Raj Singh. I'm a product manager for the InterSystems IRIS data platform and focusing in developer experience. One of the main things you may know that I work on are the extensions to Visual Studio Code. And most notable among those are the ObjectScript extension. And I also work on a lot of other open source initiatives we have going on here, as well as some other things. But I would be remiss if I didn't mention my colleague, Bob Kuszewski, who is also a product manager for developer experience. And he is responsible for a lot of the features you're going to see today and help put this presentation together with me, and will be joining me in answering your questions at the end of this talk. So what we're going to do today really falls into three areas. First of all, I'd like to tell you just what are your development options for Python. Over the years, those have evolved to be 5 different ways you could use Python with the data platform. And as the language and our customers' needs have evolved, those choices have evolved as well. And that can be a little complicated. So we're going to just cover those and get those straight. And we're going to move on to, okay, so given all these options available, when should I use which and how do I make that choice? And finally, we're going to play with some code so you can see really how it works. By the end of this half an hour, hope you can feel much more confident in choosing which strategy is right for your use case, your business case, and which will help you, move a lot faster on your development efforts and not waste a lot of time flailing around trying to figure out what's right for you. So let's start off with, why are we putting so much effort into Python and making it such an important part of our technology stack with the data platform? A lot of these reasons are obvious, and some of them will be a little bit less obvious. But first of all, it's the ecosystem. It's all about the ecosystem of libraries and code and support available on the Python platform. Python excels in the areas of data science and IoT and cloud, obviously really important technology areas today. And even more than that, when you think about applications that have already been built, these are the areas in which a lot of customers are adding new functionality. So that becomes really important as you move forward in new efforts to have these tools available to extend existing applications. Simplicity. Python has grown so much in popularity because it's easy to learn and easy to get better at. Easy as you become a better programmer, a better developer, it's easy to create better and better programs without throwing away old work. And then a little bit of an inside reason, it's Python is a great language in that it's designed to be embedded and extended. And so it was very straightforward to make it a part of the IRIS data platform. ObjectScript and Python actually share a lot of similar characteristics, so it's a match made in heaven. But I think the biggest reason is obviously the workforce implications of being able to use Python with IRIS. It's, there are so many more developers who are familiar with Python than with ObjectScript, so it really allows you to be a lot more flexible and nimble in creating teams and staffing up projects and basically getting your work done and achieving your development goals. It's the #1 language on the PIPL or PIPL Popularity of Programming Languages chart, which is the methodology involves basically looking at Google searches for languages. In addition to that, it's the #1 most wanted language in Stack Overflow, which is a developer survey that goes out every year and asks specific questions to real people. And also in that survey, it turns out to be the #1 server-side language. That's my interpretation. They didn't call it that, but if you look at this list, which you can see here in the bottom corner, the top 3 languages, JavaScript and HTML, those are web. Then SQL comes in third, which is something you use across all languages, obviously. And then right behind that is Python. And you can see what's most interesting about this chart to me is that there's a big dip after Python in the popularity of the other language we normally consider to be enterprise class server-side languages. Java trails behind by over 7 percentage points, and everything else is way back there. So I don't think it's any secret or any new information for you that Python is a very key part of almost every company's development future. So here's the way, or the 5 ways you can use Python with InterSystems IRIS. On the left, the first 4 ways involve Python talking to IRIS out of process, which means it's not sharing memory. They need to communicate via some kind of channel. Finally, which is only about 5-6 months old now, is embedded Python, which allows you to communicate with IRIS in process. Python code and your data in IRIS sharing memory, no latency or very low latency. The potential for the most highly performant applications that you can build. But we'll get to that in a minute. First of all, let's start on the left with some of the relational drivers. So we've had PyODBC for a long time, and we just introduced DBAPI in version 2022.1. So PyODBC, it's an ODBC driver that you install, lets you work with your IRIS data as a relational model. And a lot of people have all their data in relational tables that can be queried via SQL, and this works great for them. There's a growing developer community who like the DBAPI flavor of working with relational data, and so we have introduced a DBAPI driver for that community. Right in the middle of the screen, you have IRIS Native, which is a way for you to write Python code that manipulates globals directly. And we have a Python native driver for that. Now, Python Gateway is a little bit of an odd duck out of these 4. In the other 3 that we just talked about, your Python code is talking to IRIS, is initiating the communication with IRIS. The gateway is the opposite. Flips the script on that a little bit, where something happening in IRIS requires something to happen in the Python, or requires the Python program to do something, and it calls out to that Python program. And so that is a sort of a specialized use case, but when you need it, it's really important. So that's important to know about. And finally, embedded Python, which I mentioned, is Python running inside the kernel, is a great way to build a series of applications. Hopefully, more and more as the features evolve and mature, and you get more comfortable as a customer, a lot of your solutions will migrate towards the embedded Python. Okay, so let's talk a little bit about, given those 5 different options you have for building applications or solutions. So how do you know which one is right? Well, I think I hinted at a little bit, but let's just go through it in a more formal way. So first of all, sort of the granddaddy use case, the most common one in the industry is full stack application development. You're writing a pretty standard web application, has a user interface, and it needs to populate that user interface with data from a database, and pretty standard development. Use SQL for your relational tables in a database, show the results on the screen, have the user do things to change what the database queries. And so pretty standard web application. Everything is relational. You need SQL. On the other end of the spectrum, a much more unique case is where you have a very data-intensive Python application. Instead of needing to pass back maybe tens of K or hundreds of K of information, like you would in a web application, you may be passing back and forth megabytes or hundreds or thousands of megabytes of information between your Python code and your data layer. And in that case, you need it to be very, very fast, and you need as low latency as possible. And there's a range of analytic applications and machine learning and AI applications that fall into this category. And then one use case, which is really important to us as in our IRIS ecosystem, is the situation where you already have an ObjectScript application, maybe complex, maybe many years old, maybe decades old. It's working really well for you, big installed customer base. You don't really want to mess with what's working well, but it needs some new features. And you really need to modernize that thing. And you really would like to use Python for that, maybe because of the ecosystem, play I talked about, where there's some libraries you really want to take advantage of, or maybe it's just that workforce issue. It's much easier for you to spin up a Python team, development team, than to find your ObjectScript developers up to do that project. And so you'd really love to keep your application in place, but add features using Python. So in the first case, this is a great, as I hinted at, this is your pretty standard DBAPI or PyODBC strategy, where you're just going to hook up a driver to the database and go along with your development efforts. So what's different from in the past is that if you were to write this in pure ObjectScript, you needed an ObjectScript development team. Now you can pretty much have a development team which only knows Python and SQL, which really allows you to have almost any developer on the planet be able to build those applications. In the second case, on this very sort of not that exotic, but it's a much more specialized use case, you really want to use embedded Python. And this is what embedded Python was designed to do. Pass a lot of data back and forth between code, really not even pass, but merge data and code in a single location. And finally, for those of you who are augmenting existing applications, you also want to take a very close look at Python, embedded Python, I mean, but you want to look at a different flavor of it. You want to look at the way you can create Python class methods or functions right in your ObjectScript classes. And we'll look at that as well. So that should give you a better idea of why we have these different strategies available. And now let's take a look at how they, what they actually look like from a coding perspective. So we're going to go through 3 demos here. We're going to look at the SQL use case using DBAPI. And then we're going to take a quick look at the native API and how that works. And then finally, we're going to look at a little bit of the flexibility of the embedded Python solution. There are many interesting avenues. Even if you only stick to embedded Python, there are so many different things you can do. It's very exciting, and we'll only be able to hit on a few, and we'll only be able to hit on them very lightly today. But I hope it whets your appetite for more. Okay, so now let's look at some technology demos here. Let's start off with the DBAPI demo. Just to let you know, all this sample code is available on GitHub, and I'll share that link with you at the end, so you don't need to write anything down or take screenshots. You can just follow along for now. And when you see the GitHub repo, it will be divided into 3 folders: DBAPI, native, and embedded. And so we are going to go through those now. So I have a very simple program here, which inserts, well, first creates a schema, then it inserts some data into that schema, and then we're going to just do a simple query on that and iterate through the rows. But that's basically, the heart of any application. And so this is a great, quick little code snippet on how to get going. So I am going to start up a containerized version of InterSystems IRIS here and install the DBAPI driver automatically or in my scripts. So if you know how Docker files work and all the container automation, you'll be able to look at that code and see that happen in here. And we also have a lot of this available in the InterSystems development template. A lot of ways to learn more about that. But now this is up and running. So I like to just click over here using my Docker extension to VS Code and right click on DBAPI and attach a shell this way. So now I get a command line on my container. And I've done so many demos recently that I need to remember the exact instructions. There's a little README file in each of these folders that tell you exactly what to do. So I've done steps 1 and 2 now. I'm just going to go into the folder where my code is. Type Python 3 DBAPI. And that program executes. Remember, I installed the driver when I fired up the container. That's an important step. But after that, you need to do nothing more to get this code to run. So let's look at this code and quickly see what it does. It's very simple, so it won't take long. So the first thing we do here is we create the table. We run very standard SQL, create table, blah, blah, with 3 different property or field or column types: a varchar, an integer, and a float. And we execute that SQL, and that creates our table. Now it gets a little bit more complicated here. We create a little loop to create 10 rows of data with a little bit of variation in it. And then we just run insert statements to put that data into the database. And then finally, come down here and we select that data and show it. And you'll see that right here. So if you notice here, every row we inserted, we use the same varchar or string. So you'll see down here, that's the same in each place. The second column or property, myInt, we actually incremented that by 1 each time, and you'll see that here. And for the third one, we multiplied that value times this number, and you'll get that here. So very simple way to quickly illustrate the idea. And that's really all you do to get going with the DB API. Now I'm going to quickly jump over to the management portal and show you what that looks like. So I'm not going to go through the management portal navigation details here, but you'll see you can do the same thing here. I'm going to leave that up for later. Okay, well, that's it for the DB API. Now I'm going to jump over and show you very quickly how to use the native API. So if you manipulate globals, you'll be interested in this. Oh, sorry. I forgot to shut down my container, which is an important step. if we want to start up another one. So this is a very good practice in not just doing demos, but in your development. If you do containerized development, you have complete control of the environment. You know exactly what drivers or what libraries are running on there. So it's good habits to have completely separate environments for everything. So once again, I'll start that up while I talk about the code. So Iris native, as I said earlier, is a way to manipulate globals from Python. Globals are really, in case if you're not familiar with them, they're a type of array structure. So nothing really too exotic and scary. But globals are officially defined as multi-dimensional array. And what we're going to do in this demo is take some JSON objects and represent them as globals in the IRIS database. So here you see two JSON objects, sample map and sample child. They're related through this parent-child relationship. So sample map has no parent, sample child has a parent of ID 001, which happens to be sample map. So, you may build any kind of sort of relational model here. It's a great way to represent relationships. So now that this is up and running, let's once again open up a shell, attach a shell to that instance of Iris. Open up our README so we know what we're doing here. Nope. Okay, go back into that opt-iris build source directory. And let's run this program and see what it gives us. Okay, so we didn't print out the globals here. We just printed out the successful connection methods. So we have to go into the management portal to see what those look like. So now since I started a new copy of Iris, I had to log in again. And these are not relational data. This is global, so I can't look at it through SQL. Okay. So I have to go through the globals page to see these. And I'll go down here and find my mind map. Click on view that, and you'll see we've inserted that JSON data into this global structure. Okay, looking back at the code for what we did here, we took these JSON objects, we created a connection to the database, and then we went into this function to write them from JSON into this globals array structure. So all we did here was iterated through each key in the JSON object and set the mind map global, set a child of or a branch of the mind map global to have these data objects. So under mind map, we have an ID with a value of 001, and then we had topic chicken and no parent, and you'll see that right in here. So for 001, we have an ID value of 001, parent is blank, topic is chicken. For the second one, 002, we have an ID, 002, parent is 1, and the topic is spicy wings. And so a quick little simple example of how to do that. Okay, so finally, let's talk about embedded Python, which I think is the most exciting Python development we've had in a long time. I can't wait to show you some of the cool features here. So let's get started by first launching our container, of course. So we're going to launch Iris, and we're going to add to it a sample data set on the Titanic passenger list. Titanic is the ship that went down many decades ago. Okay, and that data automatically gets loaded into Iris by the by the scripts. So we can go right in here. And let's just take a quick look at that data set. So we created this data.titanic table. Let me enlarge that a little bit for you. So you'll see here, it's a data set like many others. You know, the important thing about this is that when you come to a new data set, it's hard to get a feeling for what the values are. What are the ranges? What's the shape of it? Is it ready for use in an application? How fit for use is it? And that's why a lot of people apply pandas to this problem of exploratory data analysis to understand the shape of the data, whether the values make sense or not, and what types of applications they can build or would be appropriate to build for that on top of that data. So what I'm going to show here are some Python methods to explore that data. So first of all, I named my function Explore. We're going to take a look at some of the properties of the data set and just get a feel for what their values are. So let's once again log into our container by attaching a shell to it. In the source directory, looking at this explorer.py file, and I'm going to run that. When you're using embedded Python, instead of using your regular Python command, you use IRIS Python, which is our built-in version, which takes care of making sure it recognizes the location of libraries a little bit better, saves you some time and headaches. So I'm going to run that, and we get a couple things out of it. First of all, we get a list of properties and their data types. And then for a particular property, survived, show you a little bit of the shape of that data. And let's look at this code and see how we did that. So for the property section, we ran a here we are in the get dataset properties function. So basically, run a SQL command on IRIS, select top one, just to get one row from the dataset, the Titanic dataset, and send that as a SQL query. And we only ask for one row because all we're really going to do here is look at the metadata, look at the columns metadata. And so we grab that with this little command here on result set. So here we're reaching into the result set and really doing a IRIS command on there. And we are just looping through those, looking at the column name and the client type, which is the data type. And we're putting those on a list. And we are basically returning it to the caller, which is just a little. All it does here when it returns it is takes that list, translate it into JSON, do a little indentation with 2 spaces, and print it out. This looks a lot nicer if I put this into nice little window here. VS Code recognizes this as JSON, so it'll show you all the properties, passenger ID, survived, the whole thing. Now what we did after that was we took this survived property and then we called our explore function. Let's take a look at that function. So explore, once again, starts off with the select statement. The survived data type was, what type was that? 5, which is an integer. So it's not type 16. So we don't go into that section. We come down and it's not about Boolean. And so basically all we need to do is select survived from the data set, get back all the values into a variable, and we just can automatically convert that to a data frame here. This is a built-in feature of embedded Python, which is really exciting because in one step, you have a pandas data frame. And that is so amazing because you can use the pandas describe command to get a range of really great information very quickly. And so you'll see I won't get into the describe command. You can look that up in the pandas documentation, but it's a great way to just get a quick overview of the shape of your data. And don't have to describe it because basically we do a little bit of manipulation to make it look nice. And we spit back out this information, which I will once again paste in here so it looks nicer. I'll use VS Code's Beautify extension. So this is the standard information how to describe is what you see at the beginning here. Count of values, mean, standard deviation, minimum, maximum, and some interquartile values. What we added there in the code, which I won't go through in detail, but we created these bins of 10 equal ranges so that you can create a nice histogram to display on a user interface, which is really nice if you want to get a quick overview of the spread of your data. And you can dig deeper into this, into the details of this code here. But basically, there's a lot of, obviously, just sorting numbers into buckets, which is not so interesting for a demo. Now let's move forward, though, to our final situation, which I want to show you, which is taking existing ObjectScript class and adding some Python to it. So we're going to do the same thing. We're going to use that describe command again, but this time we're going to call that from an ObjectScript class method. So you see here I have a little sample class, embedded Python, and I have a normal class method called dfExample, which if you know ObjectScript development will look very familiar to you. And here I just set a particular variable to the return value of the create data frame class method. And I'm passing a string to it. So jumping down here to create data frame, go along and it looks like a traditional ObjectScript class method until you get to the end. And here you have brackets, language equals Python. Wow. So this is the exciting new part. So now everything inside here is going to be actually Python code, but it's going to be working with data which came from ObjectScript. And that type conversion is seamless and transparent. So I won't go through this in detail because we just did it and it's very simple. We're just creating a data frame you're writing a SQL statement, running against the database, transforming that into a data frame and using the pandas describe command again. But we're doing it within an ObjectScript class. And that's really the new exciting part of this. So the response is the same, but now we have actually melded ObjectScript and Python in a single development environment, which is great for those mixed projects that you may have. Okay. So I hope that has given you a good flavor of all the different things you could do with Python and how flexible our implementation is. So just to summarize, we looked at some client application use cases where you have relational data. And if that is your case and you're making web applications, focus in on DBAPI and PyODBC. If your application happens to be based on global data structure completely, you may want to look at the native API, but you're probably in the DBAPI PyODBC bin here. If you're doing anything with stored procedures and functions and triggers, or working with a lot of data and wanting your data very close to your code, you want to be in the embedded Python area. It may be Python Gateway if you have a big legacy application sitting out there and it can't move, and you really can't tightly integrate Iris and your Python application. It may be a good case for Gateway, but you probably want to be, if it's new development, greenfield development, you probably want to be in the embedded Python area. And as we saw at the end there, especially if you're augmenting existing Iris classes, embedded Python is the way to go. And then if you're working with interoperability, that's another place where Python Gateway is a very good option using PEX. But it is possible to do some of that work with embedded Python. And finally, if your project really involves a lot of globals manipulation, focus on globals only, you can use the native API, Python Gateway, or embedded Python for that kind of work. So I hope you have a better understanding here of all the ways Iris has implemented Python support, and met developers where they are on whatever types of technology, areas of the Python ecosystem they're more comfortable in. We support the whole gamut. And with that complexity, or with that flexibility and that power, comes some complexity. And I hope this presentation has helped you understand figure out your way through that. And so please go check out the demo code, play with it a little bit. Here are some useful links for your driver downloads and some key documentation pages to get you started. And thank you so much for listening to this. I'd love to hear your questions now, or you can email me anytime. Email is in this presentation. And finally, I'd like to welcome you to join us at Global Summit this year at the end of June in Seattle, Washington. And it's coming up quick. You can hear a lot more about Python and get hands-on and work on a lot of technology that we have available, and meet the actual developers, and get a lot of really in-depth knowledge, as well as some terrific keynote speakers. So thanks for your time, and please, any questions you have, I'd love to hear them.